In this video, I'm going to show you in a simple and easy to follow way how you can prove the identity that sine 3x is equal to 3 sine x minus 4 sine cubed x. And now the first thing you need to do is you need to do something quite clever. And it is the most obvious thing in the world once you've seen it, but it's not necessarily obvious until you've actually seen how we do it. So sine 3x, unsurprisingly, is the same as sine 2x plus another x. So you can split the 3x into 2x plus x. And what this does is it allows you to use this identity. So we've got the sine a plus b identity. And what we can then realize is that in this case, a is going to be 2x and then b is just going to be x. We can then substitute and we can get an expression for sine 2x plus x just by doing that simple substitution. Of course, from the first line, we know that sine 2x plus x is just sine 3x. So we can say that sine 3x is equal to this. So all we've done is split up the 3x, use the simple identity, and then do a simple substitution of a equals 2x and b equals x, and then we've got this nice expression. We then have to think about what we can do next, because this is not a very nice expression. We need to start heading in the direction of what we're trying to prove. So I'll look at this and look at the 2x's. So this sine 2x and cos 2x we want to get rid of. So what we can do is use some other identities. So sine 2x is 2 sine x cos x. And then if we recall that cos 2x is 1 minus 2 sine squared x, we've got two simple substitutions that we can do. So we're going to substitute into the red and substitute into the green section, and we then get this expression. This expression actually looks worse than the first expression. However, with some simple algebra, we're going to be able to multiply this out and start simplifying, and it's going to head in the direction of the final proof. So let's take this line and start tidying it up. So of course we can multiply things out. So what I've done here is I've just multiplied out each of the brackets. So we've got the cos times the cos giving a cosine squared. And then 1 multiplied by sine gives a sine term. And then we've got a minus 2 sine squared multiplied by the sine. That's where I get the sine cubed from. We've then got this cos squared x here. So the cos squared we don't want, so we want to do something to get rid of it. And you may recall the simple identity that sine squared plus cos squared equals 1. And if we rearrange that, you can get an expression for cosine squared x, and we can then substitute that. So we then substitute that in. We then have something that needs to be multiplied out. So obviously just do 2 sine x multiplied by the 1, and then the 2 sine x multiplied by the minus sine x squared, and you get this expression. The last step is simply to realize the 2 sine x plus this sine x, that gives you 3 sine x's, and then you can combine the sine cubed x's, and then you end up with the final expression, which is what we wanted to prove. So this is how you prove the identity. I hope this video was helpful to you, and you can now replicate this proof. Finally, thank you very much for watching, and like and subscribe for more of this content.